Welcome to episode 122 of Paper Brief, where we delve into the latest research. I'm Charlie, your host, and together with me is Cleo, an expert on the technical and machine learning side of things. Today, we're discussing a fascinating paper titled Multimodal Data and Resource-Efficient Device-Directed Speech Detection with Large Foundation Models. So Cleo, could you kick us off by explaining what device-directed speech detection actually means?
Sure. Device-directed speech detection is about identifying when someone is speaking to a device, like a smart speaker, instead of just chatting or talking in the background. It's key for voice assistants to know when to react.
That sounds like it could be pretty challenging. What's special about the approach this paper takes?
What stands out is their focus on decoder-only large language models, or LLMs, for speech detection. These models, like Falcon and Red Pajama mentioned in the paper, have shown strong performance across many tasks compared to other types.
I see. But with all this talk about large models, how does that work with resource constraints?
They use a technique called LoRa, which fine-tunes the model without changing its weights directly. This makes it possible to deploy a generic LLM on a resource-limited device, which is pretty cool.
Resource efficiency is definitely a hot topic. Now, doesn't training these models require a lot of data?
It usually does, but the kicker here is that their method requires only a small amount of training data, making it way more practical.
Got it. Could you give us an example of what counts as device-directed speech versus just regular speech?
Of course, device-directed speech would be things like set an alarm for 8 a.m. or tell me a joke, whereas regular speech could be something like can we talk or I was trying to do it.
Interesting examples. It's all about context then. How well does this system perform in real-world scenarios?
The paper shows that it performs remarkably well, especially in low-data environments, which is a surprise. Small, specialized encoders even outdid the larger generalist models.
That's impressive. This kind of efficiency could revolutionize interactions with devices. Any final thoughts before we wrap up?
Just that this is a huge step forward for making smart devices smarter without sacrificing performance or requiring tons of training data.
It sure sounds like it. Thanks for the great insights, Cleo. And thank you, listeners, for tuning in to Paper Brief. Catch us in the next episode for more cutting-edge paper discussions.